How many alkenes have the molecular formula C5H10? What are their structures and IUPAC names? Specify the configuration of stereoisomers as cis or trans as appropriate. So let's first draw out the first one and figure out how we can form other alkenes that also have the same molecular formula. And so we have 1, 2, 3, 4, 5. Let's see if this structure will be correct. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I do have my C5H10 correct formula. We can double check our valence electrons. I am expecting 5 by 4 plus 10, which is 20 plus 10, yielding 30 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So I do have my 30 electrons. I can double check my formal charges. Each of the hydrogens are only making one bond. So a formal charge of 0. Each of the carbons are making the correct number of bonds, which is 4. So it's going to be 4 minus 4, yielding 0. And so this is a valid structure. If I'd like to draw out the line structure, then it would look like that. Now, I can decide to move this double bond around to form other structures with the same formula, and that will give me this. Can I move this here? It would just form the exact same thing. And so in terms of moving the double bond around, that's the most that we can do. Now we can decide to move individual methyls around. And so let me actually draw these out. In this one, I simply moved this double bond here. So that is the structure. Now I can change it by, let's say, I keep the double bond here. Let's say I hypothetically move this chain instead of being at the end, I make it here. And so I have CH3 attached as a methyl group, which will leave me with a H. You can double check everything still remains. 3, 4, 5, 6, 7, 8, 9, 10, and our carbons are still fine, our valence electrons are still fine, and our formal charge is still fine. And so if I draw this out, it will look like that. So I have my double bond. Okay, and then I can decide that rather, instead of having the double bond here, I can instead just have it here with the same methyl chain still attached. And so this H will come here. Sorry, and then I can move this methyl onto this carbon. Just so that the bonds all make sense. Double check you still have the same amount of hydrogens. 3, 6, 9, 10, same amount of carbons, everything still remains fine. If I drew that out, that would be this is CH3. So far we have 4 of these structures. And you can continue playing with the chains in order to move the double bond around and create another structure that remains the same, and you'll end up with 6. Do this one. Okay, that's it. Now we go about naming them. So let's identify the longest carbon chain on each. Here I have a straight carbon chain with 1, 2, 3, 4, 5, and so this is going to be pent. Again, it hasn't changed, it's still pent. Here my longest carbon chain is 1, 2, 3, 4, because this is a methyl group, and so this one is going to be bute. This one too, let's look, 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5. So this one is going to be pent. Here I have 1, 2, 3, 4, 5, 2. So this one is going to be pent. And lastly, here I have 1, 2, 3, 4. So this one is going to be bute. Next up, I'd like to identify the position of the double bond. And so here, I can see that if I count to minimize the position of the double bond, this is going to be 1 ene. This is going to be on carbon 2, so it's going to be 2 ene. We want to count from the direction that puts the double bond on the lowest number. So like, for example, if I counted from this direction, that would put the double bond at carbon 1, 2, 3, instead of 2. 2 is lower than 3, so instead I count from this direction. Here, again, I have it on carbon 1, so 1 ene, 1, 2, 1, 2, 3, so 2 ene, 1, 2, 1, 2, 3, so again, 2 ene, and then 1, 2, so 2 ene. Let me just ensure everything checks out. Sorry, this structure has too many carbons on it. So this is supposed to be butene. And then, which looks exactly like this one. Right, just one moment. Let's write all of them out instead of their line structures. So first off, I could have the double bond there. Next up, I can decide to move the double bond. Okay, and then I can see what happens if I move it here. Okay, so I see that if I move it to this position, it's the same thing as having this, instead this carbon is this carbon. So this is a copy of this. And so I've moved the double bond as much as I can. Let's see where I can bring in methyl chains. Okay. Next up, let's see how I can move the double bond around when I do have a methyl chain. So let's say I move the double bond to this position and keep the methyl chain on this one. And then just ensure everything has 4 bonds around it in terms of the carbons. Okay. And then we know that if I move the double bond here, that's the exact same thing as what I had initially. And so let's instead move the chain. So far, let's count our structures. 4. Okay, we see that this isn't, let's actually see. So carbon 1, 2, the double bond, the methyl. So we know that this is just these two are the same. They're just in reverse. Okay, and then it looks like these are all of our structures. Let's just double check the ones given in the question. Oh, there's one more place where we can have a double bond. So there are actually 5 structures. E is not valid because, okay, so in E I have a methyl chain on carbon 1. Having a an alkyl group on carbon 1 is exactly the same thing as having it straight chained because I could just bend that carbon back into this position. So A and E are the exact same thing. Sorry, A and B. Sorry, E and B are the exact same thing. And so there's no reason to have both of them. Okay, so let's go about writing our last one. And that is if I bring the double bond onto the group here. Okay, so I have 5 valid structures. Let's go about putting in the length of the carbon chain. So the prefix. Here I have my longest carbon chain is 5, so the prefix is going to be pent. Here again my longest carbon chain is 5, so the prefix will again be pent. Here my longest carbon chain is 4, so my prefix will be bute. Here longest carbon chain is 4, so again bute. And here again my longest carbon chain is, so I want my longest carbon chain to include the double bond. And so I'm going to count 1, 2, 3, 4 that way. And so this is also going to be bute. Now I go about listing where the double bond is. So on this one, it's on carbon 1 if I label them. So this will be pent 1E. On this one again, let's label them. This one doesn't matter which direction I choose. Sorry, it does because I want to hit it on carbon 2. And so this one is pent 2E. This is going to be bute 1E. This is going to be bute 2E. And this one, since this is carbon 1, because I want to hit the double bond as soon as I can, so this is carbon 2, 3, 4. So this is also going to be bute 1E. Okay, next up, I want to assign positions for my side groups. And so here, we can begin counting this way. I have my methyl on carbon 2 because this is my methyl group. And so this will be 2 methyl bute 1E. Okay, here I have my, if I label them for you, my methyl group on carbon 2. So this will be 2-methyl but 2-ene. Next up, here I have my methyl group on 1, 2, 3, so carbon 3. So this will be 3-methyl but 1-ene. My methyl group, I don't have any. Methyl group, I don't have any. Okay. So we've put in our side groups where our double bond is, etc. Now I need to account for this last part, which is the geometric configuration. And so let's just write down what the individual ones are. Cis means that if I have a double bond, sorry, just one moment.